The intent of this video is to talk about hydrocarbons and the oil refinery process. So first, we'll start with hydrocarbons. Hydrocarbons are molecules that are made up of only hydrogen and carbon atoms. As your book states, they follow this common naming method where they're going to end in ANE. They're going to end in ANE, as long as they all have single bonds within the molecules. And we're usually, when we talk about single bonds, we're talking about the bonds between the carbon molecules. The prefix in front of the ane ending, the ane symbolizes, again, single bonds between our carbon-carbon molecules. The number, the prefix in front tells us how many carbons there are. So for one carbon, we use the word meth, so methane. If it's 2 carbon units, then we use the prefix eth, ETH, for ethane gas. If it's 3 carbons, it's prop, P-R-O-P is the prefix. For 4 carbons, it's bute, B-U-T. And then for 5, 6, 7, 8, 9, and 10, it follows the standard polygon prefixes. So 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So the first 10 hydrocarbons names are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. And remember, the ane at the end just symbolizes that they're just single carbon-carbon bonds in the molecules. Okay? If you're looking at hydrocarbons, you'll notice that the smaller the number of carbons, the lower the boiling point. Okay? So a boiling point is the temperature at which a molecule turns from liquid to gas. So methane, is at room temperature at 25, it is a gas because its boiling point is negative 161 Celsius. So if you can find a place on Earth that's minus 162 degrees Celsius, you'll find methane as a liquid. But I don't know if that place really exists. I can't think off the top of my head a place that cold on Earth. So methane is a gas here on Earth. Okay? We can start to see maybe, so methane, ethane, propane, and butane are all going to be gases at room temperature. Okay? But when we hit pentane, 36 degrees Celsius, we're starting, that's about body temperature. We're 37 degrees Celsius, so hotter than room temperature for sure. So we can start to see that pentane, hexane, heptane, octane, nonane, decane, so on and so forth are going to be liquids at room temperature. So room temperature is about 25 degrees Celsius. Okay. What else do we know? So these are the Lewis structures. So these are called the structural formulas. And then, boy, don't we get tired of writing out all this stuff, all these carbons and hydrogens. So we start to write it in the condensed formulas. So you can see how butane here that has 4 carbon molecules gets shorthanded to this. And so we put it in the order that it follows. So this very first carbon over here has 1, 2, 3 hydrogens bound to it. So we would write CH3. Then the carbon it's bound to next only has 2 hydrogens, so you see CH2. The carbon that's bound next, carbon 3, has 2 hydrogens off of it as well, so you see CH2. And the very final terminal carbon, carbon 4, has 3 hydrogens off of it, so you see CH3. Essentially, for all these formulas, except for the very first one, you're going to see CH3s as bookends on either end, and then all the carbons in between are all going to be CH2s. Okay, and that's because of the Lewis structure. Like you can see over here that all the carbons in between only have 2 hydrogens bound on them. Okay, so these are hydrocarbons, and this is what's in the mixture of that crude oil. Okay, so we've got methane, ethane, propane, butane, pentane, and all the way up to dodecane, C20s, these massively long carbon units. Okay, you might one thing think, Dr. Hughes, I thought you just said that these 4 are all gases. How are they in crude oil? Well, just think that they're kind of trapped by all the other hydrocarbons. So we say this thing in chemistry, like dissolves like. So hydrocarbons will help dissolve other hydrocarbons. So you can see if you have a lot of heptane or octane or 20 mers, the 20 carbon units, the long ones, those can kind of hold on to and grasp these methane, ethane, propane, and butane. So crude oil that comes out of the ground is just nasty black mixture of stuff. So it's taken to a refinery to purify out that all these different hydrocarbons, and all these different hydrocarbons have different uses. So once at the refinery, the crude oil will be put into a broiler, and I forget how many barrels they can boil at a time, but it's a lot, it's massive. So all the crude oil with those mixtures of hydrocarbons is put into the broiler, and that broiler is heated. Okay. Remember, as you increase the number of carbons in the chain, you also increase the boiling point. So they're all liquid to begin with, and if you add just a little bit of heat, tell you what, that methane, ethane, propane, and butane are going to start jumping around real fast and fly into the gas phase, because remember, they boil at pretty much negative temperatures. So they're going to be the first ones to jump off and turn into gas, and then they're going to flow into this distillation tower. Okay? Distillation tower is heated, has a decreasing temperature as you go towards the top. Okay, and so sometimes this is also referred to as a condensation. It could be a condenser or a condensation tower. So it's really hot towards the bottom, and then it's cooler at the top. So those very early hydrocarbons, C1, 2, 3, and C4, are going to turn into gases, enter this distillation tower, and at 400 degrees, they're still going to be gases. So they're going to travel up, because gases are going to float up, and you're going to travel up. It's still cooler, and it reaches about 40 degrees Celsius as cold as it is toward the top. Guess what? There are still gases, and so they're siphoned off, and those are what we call refinery gases. So that's carbons 1, methane, ethane, propane, and butane. Okay, those can further be separated to get propane for propane tanks. The methane can be used for natural gas, and the butane can be isolated for butane torches for welding, for some welding purposes. Okay, so, but we still keep heating our boiler, right? The crude oil is still heating. So we have essentially separated out the first 4 hydrocarbons, okay? And we still have the mixture of all the other ones to go. So as you just keep adding more heat, the smaller hydrocarbons are going to come off first. So you look at pentane through dodecane, so C5 to C12 carbons. They're going to enter the gas phase, enter the distillation tower, and they're still going to be gases at 400 degrees, let me tell you what. But as they go towards the top, as it cools, they'll reach the point where they can condense and turn back into a liquid. So once they condense and turn into a liquid, then they can be siphoned off and used for different things. So you'll see that your C5 to C12 hydrocarbons are used for gasolines. Our C12 to C16s are jet fuels to power airplanes. C14 to C16, so carbon chain lengths that are 14 to 16, is used for diesel, so tractor trailers and any diesel powered automobiles. Then you can have these larger compounds, C15 to 18, which are refinery gases, gasoline, jet fuel, diesel. And how can you get gasoline from these higher compounds is through what's called a cracker. It is a process called cracking, and you can usually have thermal cracking. So thermal cracking is where you can heat up these long 15 carbon chain length carbons, and you crack them into 2. So you can turn, a C16 into 2 8s, right? 16 divided by 2. You crack that molecule in half, and you get two octane molecules. So you can have the cracker, thermal cracking, which can then be pushed up here into the gasolines. And used as gasoline. A reformer is for use for gasoline. So this is the idea that branched hydrocarbons burn better and have less knocking, or burn more efficient in our engines than the long linear chain hydrocarbons. So let me quickly, let me just jump on a whiteboard right here and show you what I'm talking about. Whiteboard, share. Okay, so long hydrocarbons, long linear hydrocarbons would be like CH3, CH2, CH2, CH2. This is actually not what I want to do. I have to draw them. Okay, so you'd have a carbon center and a carbon center and a carbon center and a carbon center. And I'm just going to omit the hydrogens for simplicity's sake here. Okay, so how many carbons do I have? 1, 2, 3, 4, 5, 6, 7. So this is a heptane molecule. Remember, I'd have 3 hydrogens coming off this carbon and 2 on all the others in between. So what does the reforming process do? Is it takes long linear carbons and it turns them into branched molecules. So you'd see carbons coming off carbons, maybe something like this. 6, 7. All right, so see how we take this long linear molecule and we turn it into a branched molecule like this. These two compounds are related to each other because they're called isomers. It has the same molecular formula, but a different arrangement of atoms within the structure. Okay. So gasoline becomes reformed where the long linear molecules get kind of like rearranged or reformed to form these isomers that are more compact. And again, that's because those burn cleaner and better in our gasoline engines. So back to here. So that's why we have the reformer here for gasoline. So remember, cracker cracks the longer molecules into smaller molecules to be used for gasoline, and before it's moved, any linear compounds are reformed into isomers that are branched, so they burn better in our engines. Okay. So with that, we'll just finish by kind of showing what happens to one whole barrel. So for every 1 barrel that enters the refinery, about 20 gallons of that turns into gasoline that we use for automobiles or anything that's gasoline powered. About 4 gallons turns into jet fuel. So remember, that's kind of the jet fuel is the C12, C16. So those hydrocarbons. The liquefied refinery gas is 2 gallons, so that is our methane, ethane, propane. That's carbons 1, 2, 3, 4, so the really small ones. So that's our refinery gas. Other products, 6 gallons goes to other products, and this includes plastics. So plastics made from taking these hydrocarbons and making polymers out of them. So if you want to reduce your carbon footprint, an easy thing you can do is try to minimize your use of plastics, especially single-use plastics like disposable water bottles that you just drink once and throw away. Invest in maybe some aluminum or a metal reusable water bottle. It could even be a reusable plastic water bottle, just as long as you're reusing that, right? You're reducing the amount of carbon you're using technically. You can also not use plastic bags from the grocery stores. That's also a really simple thing you can do, and just have some reusable bags, or don't use bags at all and just put things back in your shopping cart, take it to your car and put them into your car directly and then carry them up yourself. You know, you don't need a bag for everything. And then 12 gallons, sorry, the last thing is 12 gallons. If 12 gallons from every barrel turns into heating oil used to heat homes. Okay. So that concludes kind of the hydrocarbons. What are hydrocarbons? What do they look like? And what's in crude oil, and how is it refined and separated into all the different uses that oil has?